Hello, everybody, and welcome back to RMUS Tech Week for 2023. This is our session for a deep dive into drone-in-the-box systems. And we, for our part, are very excited about this, as am I personally. This new product category is really an opportunity for loads of new use cases, maybe even entirely new markets for these types of products and services. So super exciting. I'm here with Curt from Hextronics. Really glad to have you, Curt. Could you please tell us a little bit about yourself and your company and how you guys got to this point?
For sure. Thanks for having me, Fraser. And pleasure to be here with RMUS. So, Hextronics kind of started from many things I was doing growing up. I was always into developing products, methods of transport, little electromechanical machines and systems. And then I got into really the capability of the drone industry as it was then, as it is today, and as it will be in 5, 10, 15 years, and decided that I really wanted to play a role. And the best way to do that was to make a product that quite a variety of people could use for different industries, start being able to integrate it into their workflows and take ownership over the entire workflow solution of what really makes autonomous drones exist and play a role in society. I started off always having a interest of all the movies growing up where you see robots flying around doing things as part of society automatically, understanding what really some of the main blockers was to why aren't there drones flying around every day, and came to the point where I understood that there were still problems yet to be solved, and that's where I started off focusing my time. So I graduated from the Georgia Institute of Technology out of Atlanta in the U.S. With a degree in mechanical engineering, and from then started basically in my apartment, and then laboratory, and then garage, designing the first iteration of our drone in a box technology. And so it started off. We really understood that, hey, drones aren't flying around everywhere automatically because they don't really have a home or a nest. And if they do have a nest, it costs a fortune, and not everybody or every company can buy one, but only the groups that are using them for extremely industrial, high tech applications. And so from that, we got set to designing a system for some of the most readily available and open drones at the time, the Mavic 2, and really started to understand, okay, well, if the drone needs a spot to rest and stay, then it also needs to refuel, be maintained in any weather condition, and be really easy to command and control and operate from anywhere in the world. So that took us to our initial product, the Hextronics Global, of which we designed and manufactured in my garage that I had growing up, actually in South Florida, here in Miami. And we made the first initial batch of units from a group of high schoolers that came in and interned in my garage. And so that, as you can expect, was a great time. I didn't have too much to pay them because that was a startup, so I just got them free Publix sub sandwiches every day, and trained them how to code in C++, how to screw and rivet, and bend sheet metal, basically, and then how to fully create a relatively complicated electromechanical system. That was the global. And then near the end of that initial development, we started refining that product to the point where it reached over 10,000 continuous cycles of operation, which was definitely a challenge. And in doing so, we really started to make a name for ourselves in the industry, being at specific expos across the U.S., across the world, working with partners that have really helped us and elevated us along the way. And since then really gotten the opportunity to design even more advanced systems and hardware for drone autonomy in a sense of being open to other drone manufacturers, operators, and software developers all throughout the industry. And so it's been quite a journey so far. Right now, we are in over 25 different countries with over 100 products shipped internationally, and it's really starting to heat up this year. I'm sure most everyone here has their pulse on the industry and knows that the gate is slowly opening, and we're really excited to be able to help different aspects of the industry grow along with the large players that have already had a significant impact thus far. And so, yeah, thank you, Fraser. That's kind of been our story, how we got here. I'm sure we'll talk more about kind of the products that we're really excited to design and manufacture and ship.
Great, love it. Yeah, that's absolutely a true startup story if ever I've heard one.
Mm-hmm.
And there's no better testament to how exciting the product is if you can convince people to build it for sandwiches and like Red Bull or something. So that's just awesome. You touched on something that I totally agree with. One of the most fun things about this industry is thinking about what's possible in the future. So, with that in mind, why would I want a drone in a box system? Like I've already got a drone, I can fly it wherever I want, whenever I want, with certain regulatory considerations and so on. But what's going to be the benefit to me of having a system like the stuff that you're making?
Mm-hmm. Sure. So definitely understood that it is new in the capability that it brings, and right now the some operators and people that don't really think about drone in a box too much might think, oh, you can, okay, sure, you can fly a drone on command or on schedule. Great, I guess you'll just be able to do surveillance around your property or respond to an emergency. And granted, those are two very large aspects of the utility of drone hardware for security and emergency response. But there's also another aspect that I really envision growing, and that's really the capability of the data capture that drones can create that they do currently for many different mapping and photogrammetry type operations, where you get a full 3D environment that you can recreate in real time or near real time after the fact, that gives the certain state of the world at that moment. And what you can do with that data in many different ways is an untapped market that's really going to be a massive avenue of development in software and analytics in the next 5 years, where okay, we're going to do a three-dimensional mapping of a city block or a multitude of city blocks 3 times per day, every day. And from there, we have this whole mass of data that can really be geared towards different levels of city management, uh, basically infrastructure maintenance, routine inspection of actually jobs being created, jobs being accomplished, and actions getting done, and then being able to track that over the course of time to see how the world changes based on human and society input and action, and from that really be able to take those data points as leverage to drive change for societies, communities, and nations to have some way to to um, to manage and better their society in a very efficient way. Like there's one saying that is, what gets measured gets managed, and I completely agree with that. And I believe that there's no better way to measure a mass amount of data in a short amount of time on a routine basis than using drone systems. And the only way to do that efficiently, and so it's not just someone sitting on a sidewalk for 8 hours every day flying a drone, really that's why you need drone in a box systems to deploy these on schedule, on command, or on response. And so that's kind of the avenue that we see as Hextronics as a global need, is just data capture and analytics on top of that for a variety of different applications. Now, granted, not everybody right now can afford drone in a box. Initial computers were quite expensive and can only be acquired and used by some of the top universities across the world. However, now everyone has one in their pocket, more or less. And I do see a similar avenue for drone technology and explicitly drone in a box technology over the next 10 years. And so, why would you want a drone in a box as an individual? Sure, to manage and measure your maybe property or your environment, but as an organization to really measure how actions get done within your operating environment, construction area, agriculture farm, park system, things like this, and really leverage the data capture for creating the change that are your set targets to be accomplished on your year-long goal. For instance, hey, we want to plant 10,000 trees throughout this array of 500 acres. Well, you can map that acreage every day or once per week, and really be able to, number one, analyze where the trees have been planted, and follow up on their growth on a recurring basis in order to ensure that that target has been met. And then the stakeholders can justly return the award to the contractor. That's just some avenue that we're envisioning. And then there's also, of course, first responders, and industry-wide agencies that need to be on top of any action that happens that needs to be immediately attended to. And so, drone in a box for first response, or for like gas detection, or tripwire sensing, or temperature sensor throwing an alarm. All of those are extremely critical needs that could save money, time, and lives of many of the people that to be need to be on the scene as soon as possible. Um, so really, it is data capture and first response to get the most information at a timely manner, for why you would want a drone in a box system, all summed up in a nice little box that you can put on your car, on your roof, on the ground next to you, or just on a table, or even nested into the wall of your house, something like that. I could see why people are going to need more and more drone in a box systems in the coming years.
Amazing. So yeah, it's all about the data. Drone data. We know how valuable it is, how impactful it can be in making decisions, and so it sounds like this is a really good way to get more of it more frequently, more easily. So that sounds awesome. Uh, Curt, you guys have got two products out right now. Could you sort of bring us through those in some detail?
Mm-hmm. Sure. So the first product we can talk about, and you can roll the clip, would be the Atlas. And so the Atlas is our industrial grade solution built for the Matrice 300 from DJI. And we see this drone to be one of the industry's most capable, expandable, and scalable drone systems that's already been flight proven, tested, and supported worldwide. And we really see the capability to integrate a wide variety of payloads, sensors, equipment, onto this drone to bring a new level of capacity for autonomy in action and first response that can really house the drone, refuel it automatically and rapidly in just a couple minutes, having this machine back and ready to fly. It's really something that no other system can do across the world, and that's exactly why we've designed it to do so. Because for the applications that need a drone to operate nearly around the clock, or at a moment's notice, or for continued missions, say for mapping and photogrammetry. It's something that you do need extended levels of flight time, data capture, and environmental uh, ruggedness or rigidity, and that's where we've come with the Atlas. Right now, we are shipping globally with this system, and it's being used by some of the industry leading infrastructure providers, um, energy providers, first responders, and and uh, agriculture growers across the world. And we're tremendously excited to continue bringing it to customers and agencies uh, to really solve some of their most impactful problems and really bring a solution that's built to last uh, throughout the next 5 years or so.
Awesome. So, yeah, there's using a small drone is great, nice and convenient, but of course, lots of use cases, lots of types of sensors are going to require a sort of a more workhorse platform like the M300, and so great to see that there's a drone in the box solution for that from you guys.
Mhm.
And what's the other one?
So the other system, we can roll it as well. It's the universal. It's like you said for the convenient light drone, not necessarily a heavy payload capacity or anything too strong, but really a powerful camera ready for immediate deployment and capable of being mounted on the roof of a vehicle or really mounted anywhere. Essentially, an extremely lightweight, modular, and drone agnostic system. It's the first of its kind drone agnostic nest that can perform battery swapping for a variety of drone vehicles. And so within this nest, we're fitting drones from the Mavic series. From DJI, we're filling drones from the Anafi series, the USA and the AI from Parrot, and working with Skydio on a couple of their drone hardware to fit within our Nest as well. And then a variety of other drone manufacturers now are seeing the benefit that we can provide with scalable systems that really have solved some of the most difficult problems of drone in a box, and being able to leverage our solution for their applications to scale their existing customers or their existing drone fleets to a new level, because what this essentially enables for multiple drones by single operator. And so we are tremendously excited about this unit. We've taken everything that we've learned from having our global the initial unit. It was relatively compact, but this one does it at a different scale of being compact, rugged, and lightweight, and durable, and scalable, and modular and expandable throughout the course of time, as we will be supporting a variety of drones to follow that may not be released this year uh, by a wide variety of our drone manufacturing partners that have really come to us and seen like how they understand the benefit of charging and battery swapping for a Nest, and understand that it's best if Hextronics, if they can leverage Hextronics system to do so. And so this nest, we're also really excited to be able to come in at a very competitive price point for it that enables for scalable deployment throughout, say, a city or industrial use case settings that have large acreage or area, or many different locations that each need their own nest and drone to attend to. Um, and it's truly a system that we see the capacity for growth and support uh, over the next 10, 15 years, really being able to be a foundational system that the industry can come together and leverage and just use Hextronics to solve their problems. Um, and that's what we do, and that's why we're here.
That's really cool, and we're certainly excited to get our hands on our universal unit that's coming shortly.
Mm-hmm.
The unit we saw in the video that was mounted on the top of a pickup truck, very cool. There's sort of a stationary version as well.
Mm-hmm.
I'm wondering, with the mobile version, like when we roll up to a site, what time is required to deploy that? Or any other
Mm-hmm.
considerations about having it mobile and operating at a different location every time we fly?
Yeah, so it does depend on the capability of the drone hardware within the unit, but the Nest itself has the ability to be constantly connected over 4G. We have an extremely powerful router within there that gives essentially a meter of error in the GPS location of the nest, and we have the capability to give over 50 megabits per second, basically data transfer within the between the nest and the rest of the environment. So once you deploy on scene, you can expect for some drone hardwares to launch in under a minute. Could be 30 seconds or less of simply being booted up, turn on, and then remotely flown and controlled. And with this, the Universal does have the capability of a completely open API architecture. So all components of our system can be managed and actuated and consumed basically by hitting the API of the Nest, so you can get local GPS data, telemetry of the Nest. You can tell it to open or close or swap the battery. All of that is capable with just the name of the system and the credentials to log in. And then really we do see for the drone on the roof of the pickup, or in the bed of a sedan, or even on the roof of a sedan, or just located on the ground is also easy, as you can understand being on the roof with the vibration and shock is the hard part. Really on land, it's just the same. Um, and we really see the point of utility of this being for hey, I'm at this job site. Hey, I'm at this site for search and rescue. Let's phone HQ and tell them to take a look at what we're seeing, and then boom, they can log in and remotely inspect the scene in real time from across the city, the nation, across the world, what have you.
That's for me one of the more exciting parts too. And if you're thinking, well, if you can deploy a drone in a box from the roof of the vehicle in 1 minute, well, I can deploy a drone from the trunk of my car in 1 minute. But what this system allows is, like you said, Curt, for HQ to be the one reviewing the data in real time, but also maybe that person driving the vehicle with the drone around doesn't actually need to be a trained and certified
Mhm.
drone operator. uh, that person with those qualifications could be somewhere else managing multiple drones in the fleet. So that's actually
Mhm.
really cool as well. And so while we're kind of starting to dig into the details of how the systems work, Curt, could you take us through a drone in a box system, sort of generically in detail? what systems is it employing? How does it work? Just give us some sort of granular detail on that.
Sure, yeah. So the anatomy of a drone nest, for the most part. Okay, so the main point, it's there's the shell, there's the body, everything you see from the outside, looking in, that protects and houses the unit in a variety of different weather or pressure or temperature conditions. That does need to be dust tight, weatherproof, waterproof, all of the above to sustain essentially anything that Mother Nature can throw at it. That is definitely a challenging component, and one that is tremendously important. And so, through both of our systems are built out of ruggedized materials and systems that are capable of preventing a high level of water and dust ingress. And then there goes the method of capturing the drone or launching and retrieving the drone, of which some are different methods for our systems. One is a landing pad or a roof that opens and a landing pad that raises, say for the Atlas, which we found to be one of the most conventional and lightweight, space efficient methods of retrieving such a large drone vehicle, is really to be able to have it land and take off from the same location, and also to perform basic rotor folding with our smooth rotor folding technique that basically cuts the footprint of the overall need of the nest down by roughly half the total area that it would need to be. And then there's, say, for the universal, that is somewhat of the pizza oven or the tray type design, where the landing pad is extended out of the nest in order to launch and capture the drone, while also preventing any ingress from overhead if it may be raining, snowing, or dusty out. And then we have a back door that seals the internals as well during the landing procedure. And then going inside the nest, so Hextronics is known for battery swapping. So we do have somewhat of an arm or a gantry within these two systems that can move on command within the unit with high precision in order to accurately remove and replace the battery from the housing of the drone. All done through basically top of the line electromechanical actuation methods. So we use stepper motor drivers, industry proven by the Association of Mechanical Engineers, and use those methods of actuation to reliably drive our systems that are related to over 10,000 cycles. And then there comes the mode of communicating with the drone, and so it does depend on the drone hardware and communication link itself, and that is different for, say, DJI versus Peridot, which use two different somewhat methods of communication, either needing to go through the DJI SDK, or just going through the onboard SDK provided by Parrot that enables us to use more OEM type transmitters built for this application. And then there is cellular. And so there's a cellular link to the nest that we do have in some cases, that is simply housed within the unit. And then either the antenna is extended out of the unit, or the antenna is within the unit. And in the universal, the shell is made out of a reinforced composite that enables um, for uh, for cellular signals to enter and exit the nest, and so really preventing any damage to antennas that could be placed outside of the nest in many of these different environments. Um, and then there is the HVAC system. So the HVAC system that we have as a modular component of the nest as well is one that enables it to really reach some of these critical operating temperatures that many other providers cannot really attain, and that is by using the compression cycle cooling. So basically, a small refrigerator we've built and constructed within the unit that enables for all of the internals to reside well below 80 degrees Fahrenheit or about 25 degrees Celsius for the most efficient levels of compute and battery sustainability over time. And then there is there's our inboard CPU that does all of the mechanical actuation and exposes our API for command and control to be toggled either in an air gap system, so with a local static IP, or globally from a just a routed DNS. Um, and once you have all of that together, you can actuate the nest, you can house your drone, you can maintain it in a good environment, you can swap its batteries and refuel it, you can command and control it from anywhere, and you can have the full body of what a drone in a box really is.
Very, very cool. So about this command and control piece, I know this is not exactly the area that you work in, but could you talk to us generally about the control interfaces, just briefly the options we
Mhm.
have, what those look like, and sort of different modes of controlling a drone in the box than we have traditionally had with just a regular drone?
Sure. So what everyone's used to is the remote controller, and so many of our customers and users do still require the remote controller to be in the mix. And how we enable that with automated flight is we have the controller housed in an external bay, basically a completely weatherproof auxiliary chamber that is still connected to the nest. That we extend communication to and from the nest with a ruggedized cable. And from that, you can, at a moment's notice, open up the enclosure and remove the remote controller and command and control the drone as normal. Or you leave the remote controller in the nest and you command and control everything through your laptop, tablet, or iPhone through some of the industry leading drone software providers, essentially Flightbase or Vodix. Right now are the top two that have integrated with our drone in a box systems. And so with this new mode of command and control, you have somewhat of the same remote controller experience on a tablet or laptop or desktop device. However, it can be done essentially from anywhere on the planet with a reliable network connection. And on top of this, one level removed, command and control could be the automated APIs that are also able to trigger the flight of the drone. And so instead of needing a pilot to, say, fly to a waypoint and launch from the nest, you simply can call the launch to location API provided through our system that will on receipt of that request, power on the drone, open the enclosure, drone will take off and fly to that GPS waypoint, all within a protected boundary, so that it does not, so that it flies well above any obstacles. And this is what we're extremely excited because we see that part as being the next level in how drone technology will grow in its level of advanced capability by being able to be commanded and controlled by open API architecture. And that's exactly what we support now. Anything from commanding and controlling it from a standard remote controller to controlling it from your laptop or desktop in real time or on command of a mission, or through API calls that facilitate completely autonomous drone operation or automated drone operation.
That's super cool, actually. So if I understand what you're saying, uh, we can schedule missions to happen without any intervention, or they could even be triggered by some other signal, like maybe like a security sensor on site or something like that. Is that what you mean?
Yeah, precisely. Hmm.
Incredible. That's super awesome. Okay, so thanks for all the detail there. Is there anything else we might need to implement and operate a drone in the box system?
Hmm. So what we can touch on here, I mean, you do need a reliable internet and a power source. We've gotten this capability from coming off of a 4G modem or connecting just straight to Ethernet, or in some cases connecting to a Starlink. And then there's also power input, which we do have some users right now powering it off of a generator, off of an array of solar panels, or simply just plugging into to a typical 110 or 220 wall outlet. And then there's a couple other pieces of the puzzle if you're going for an enterprise application, or basically an infrastructure analysis system that does need to incorporate with the regulations and certified bodies in the region, depending on the use case, of course, and the operating bounds. One component that is a necessity in some regard is the airspace detect and avoid systems that are able to ensure that the drone in operation always stays within a well protected airspace bubble in some regard that prevents any possibility for collision with any aircraft that is not broadcasting its exact location. And so one of the leading providers in this sense is Iris Automation and their Cassia G system, of which is fully integrated with Hextronics and Flight-Based Invotics, to ensure that there are the proper protocols and procedures taken to mitigate any possible airspace collision, and ensure for complete safe operation that has been accepted by FAA operators and many other regulatory bodies throughout the world to enable fully beyond visual line of sight operation.
Very interesting, because of course the whole, or one of the main benefits rather of a drone in the box system is to be able to operate it entirely
Mhm.
remotely without an operator on site or a visual observer. So that sort of raises another question, which is the regulatory piece. And I know this is a little different in every country. Certainly, it's a little different in the U.S. where you are to where we are here in Canada. But could you talk to us a little bit about that? I guess about whether this is a welcome development by the regulators, and does it matter what we're doing or maybe who we are when we're applying for permission to do these types of operations?
Hmm. Yes, precisely. And so our systems have been approved for operation through many partners in different countries, and they all do so by being very specific about their operating procedures and protocols, and really understanding what are the best agencies and procedures to take when operating a drone automatically and safely. And so a key part of this is airspace risk mitigation that we touched on with detect and avoid systems, but it also comes into just the standard method of how the user or pilot will operate this drone in a box system. And that does come down to the missions that are routine, what kind of flight patterns are over, could be possibly over people or over landscape that is very well understood and has very low risk of any airspace or any ground level collisions. And so with really being able to get rid of many of the possibilities of risk, it is becoming increasingly easier for operators to receive this approval. And in doing so, I don't know how the regulators really feel deep down on the advancement of drone in a box systems, but in our opinion, it is much safer than if just an individual were to take a drone out of their pocket and fly it wherever the heck they want. Essentially, being able to be tied into these airspace or these UAMs, urban airspace management tools, then feeds back that data into overarching or basically bodies that are able to inform other aircraft of their location. And so, really, if drone in a box systems are required to do this through the software that's operating them, then it's somewhat of of a of a better feeling in the regulators uh, in the regulators' mind that they know that if these systems are deployed, then it's a safe drone operation that has been thoroughly vetted, rather than one that's just being done by someone pulling a drone out of their backpack that doesn't have to answer to anybody.
That's a very interesting point, actually. From a certain point of view, there are some dangers in the fact that there's no observer. The operator is maybe somewhere else, but actually, if this operation has been worked out with the regulator and the local airspace management, and it's in accordance with all the regulations, it should actually be safer than, like you
Mm-hmm.
say, some random person whipping out a drone and flying it. So that's a very
Mm-hmm.
interesting point, actually, that I hadn't considered before. Um, Now, does it matter to the regulator who we are when we talk about doing beyond visual line of sight or drone in the box operations? Um, like, let's say if I'm working, to the benefit of public safety versus whether I'm working
Mm-hmm.
for some other commercial purpose. Is that relevant?
Yeah, so in some geographies and countries, there's different levels of certification or regulatory necessity when it comes to being able to operate a drone in different conditions. And so, in some regard, in the US, there's different levels of COAs that can be acquired to operate a drone without necessarily needing a specific waiver. And so, for some applications that are closer tied to first response and public safety. Those are ones that we see being able to be granted scale for urban type applications, whereas infrastructure management organizations or enterprise users that are using these systems to monitor their assets and infrastructure does come with a different set of operating procedures that might not be as operating within an urbanly dense environment as public safety would. And so that is how I would somewhat break it up: is operations for infrastructure management have lower risk because they are not flying over heightened levels of urban density, versus first responder and public safety users that are operating their drones automatically or remotely over more urban and population dense environments. So both of those have factors into the levels of approval and regulatory pathways.
Okay, that does make sense. So you've touched on two of the, shall we say, broad categories of use cases
Mm-hmm.
that a drone in the box system might enable. Could you talk in a little bit more detail about some of the more successful use cases that have been deployed so far, or maybe that you think are going to be big news in the near future?
Yeah, so the really one of the applications that we see the greatest level of benefit to the overall community that can use drones, automatic launching drone platforms or nests, is the capability of automated drone as a first responder, or the ADFR type of utility, where a drone is deployed on command or on call to the scene of an emergency. And so I can give somewhat of an example presentation. We might have one available. Let's see if we can put it on.
Yeah, let's roll that.
Yeah, okay. And so this is probably one of the leading drone as a first responder uh, um, operations within the U.S. So we can keep going, and the main overview of this system is the capability to have scalable autonomy by passing through limits of operation, by using drone in a box systems. So essentially, in some operations right now, they have people placed on rooftops to facilitate the drone response. Here, let's keep going a couple slides. Yeah, so back one. So this is an example of all of the 911 calls that occurred within the course of 24 hours, and then one more. And this is all of the over the course of a week. And so you can see that it's quite insane for a small community to be able to address each one of these issues and have a staff of first responders ready to see each with their see coming. Can I get the next one?
So Curt, we seem to be losing your audio a little bit here.
Yeah, it looks like it dropped off.
Curt, can you hear us there? Okay, well, we'll see if we can get Curt back. But just to sort of pick this up there, we can see with the number of calls there, the benefit of having a drone that can be deployed rapidly and automatically to those sites. It could be that many of those calls don't actually require intervention by an officer, and so that could be determined by the drone, possibly. Or, of course, if an officer is going to respond to those calls, the fact that a drone's been there first might give them a lot of information they need to be prepared to respond to that call in the right way. Maybe take additional measures, call in backup, et cetera, et cetera. So sort of clear what the benefits would be from a first responder point of view. And if there are several drone-in-the-box systems available in the community, then they're likely to be able to get to a scene much faster than an officer. Generally, a drone doesn't fly faster than a car can drive, but they may fly faster than local speed limits. They don't deal with stop signs. They fly in straight lines as the crow flies, et cetera. So this is a very good option for first responder. This really was our sort of last point of discussion for the presentation. I do hope we can get Curt back, but drone as a first responder is actually one of the use cases that I think is the most mature right now. There are some public safety agencies in the United States that have deployed this very successfully and that are publicizing their experience and their results. So this is hugely beneficial for everybody else who might be interested in this. And we've been lucky enough to sort of be on the inside of that information as well. Curt, I see you coming back here. Are you able to hear us?
Internet cut out.
We did hear you there for a moment.
Let's see.
It's very intermittent.
Clearly on.
Okay, it doesn't look like that's going to work. Let's see if we can take any questions from the audience about what you've heard so far. Please post your comments in the chat section, and we'll get them answered, hopefully by Curt, but I'll do my best to answer if I can. Okay, we'll give it just maybe 30 more seconds to see if any questions come in. If you do have any questions based on what you saw today, you can, of course, contact RMUS. You can always email us or call us. We really do love discussing this stuff, so always happy to have any questions from you guys out there. Okay, no questions so far, so I think we'll wrap it up there. To everyone who attended, thanks very much. We really appreciate Curt's contribution today. We'll get him back on here eventually, just to thank him for the big help. Do make sure to check out the rest of our RMUS Tech Week sessions. We'll be on until Friday, and as always, thank you for joining us.